Amplitude modulation technique. The basic version of the amplitude modulation is also termed as double sideband full carrier, abbreviated as DSBFC technique. The nomenclature DSBFC for the basic AM wave is to distinguish itself from its variants. Hence, in this section, if the abbreviation AM is used, unless specified, it refers to DSBFC technique. In amplitude modulation, the amplitude of a carrier signal is varied by the modulating voltage, whose frequency is invariably lower than that of the carrier. Signal is varied by the modulating voltage, whose frequency is invariably lower than that of the carrier. In practice, the carrier may be high frequency while the modulation is audio. Formally, AM is defined as a system of modulation in which the amplitude of the carrier is made proportional to the instantaneous amplitude of the modulating voltage. Let the carrier voltage and the modulating voltage small vc and small vm respectively by represented by Vc is equals to capital Vc sin omega ct and small vm equals to capital Vm sin omega mt. Note that the phase angle has been ignored in both expressions since it is unchanged by the amplitude modulation process. From the definition of AM, you can see that the maximum amplitude Vc of the unmodulated carrier will have to be made proportional to the instantaneous modulating voltage Vm sin omega mt when the carrier is amplitude modulated. Frequency spectrum of the AM wave. Frequencies present in the AM wave are the carrier frequency and the first pair of sideband frequencies, where a sideband frequency is defined as FSB equals to Fc plus minus n Fm, and in the first pair n is equals to 1. When a carrier is amplitude modulated, the proportionality constant is made equal to unity and the instantaneous modulating voltage variations are superimposed onto the carrier amplitude. Thus, when there is temporarily no modulation, the amplitude of the carrier is equal to its unmodulated value. When modulation is present, the amplitude of the carrier is varied by its instantaneous value. The situation is illustrated in the figure, which shows how the maximum amplitude of the amplitude modulated voltage is made to vary with changes in the modulating voltage. The figure also shows that something unusual, distortion, will occur if Vm is greater than Vc. This and the fact that the ratio Vm over Vc often occurs leads to the definition of the modulation index given by small m equals to capital Vm over capital Vc. The modulation index is a number lying between 0 and 1, and it is often expressed as a percentage and called the percentage modulation. It is possible to write an equation for the amplitude of the amplitude modulated voltage. We have capital A equals to Vc plus Vm, which is Vc plus Vm sin omega mt equals to Vc plus m Vc sin omega mt, Vc under first bracket 1 plus m sin omega mt.